So the plan is to line the coffin with, I've bought some black sheet to put in there, and I have a control box to mount the control logic, an IP rated box to mount some items in the coffin. We have a back plate for the control box, a few items here. We have a MCB, so as we can fuse the power supply. This is the power supply. We have a couple of connector blocks which are going to be for the 12 volts and 0 volts. We have a timer relay, a relay module, another relay module, book regulator. We have a extending arm and the brackets to go with that. We have a PIR and a little segment of 12 volt RGB pixel lighting. So the plan is to mount this telescopic actuator inside the bottom of the coffin, and the other end will be mounted to the lid, and the lid will be hinged on one side. Here we have the hinges to fit, and what will happen is we'll place it out on the drive, and when the trick-or-treaters or the Halloween visitors come along the driveway, the PIR will detect them and it will trigger the coffin to open. When that coffin opens, I have some switches that will activate, and I have one of these lights. This is to simulate a TV in a room, and the idea is that it will project in from the bottom of the coffin and change the colours and flicker and flash. So it's an easy way to get some lighting in there. Now this is going to be a standalone feature, but it will be linked into my Lightorama setup, and that's what one of these relays is going to be for. So I'm going to bring in 1 pixel channel from the Lightorama system into this strip here, and this is going to be RGB, so red, green, blue. And the way these work is you have 12 volt feed, 0 volts, and then you have a data feed that comes into this chip. So I've set one of my ports to this, and the idea is I take the 0 and like a feed off one of the lamps for the red, say, or the blue or the green output, and that will trigger this board. Now this relay board you can set to be triggered high or low level, and because these LEDs are switched on the ground side, we'll set this to low trigger, and all I have to do basically is tell the software to enable that port, and when that port's enabled, which will be enabled all the way through the Halloween show, it allows this standalone prop to run when it's triggered from the infrared sensor. Obviously when the Halloween show finishes, this relay, this pixel will de-energize and this relay will switch off, and that will inhibit this prop from running while the show isn't running. So we've basically got the base plate, which I've already fitted the DIN rail to, the end cap and the neutral earth, and then obviously you're going to bring the live in on this breaker. This is a 3 amp breaker. We have a Meanwell 12 volt power supply. This is supplies 5 amps in at 12 volts, and it draws 1.8, so that breaker is more than adequate for that. So we'll click that in there. Then the 12 volts is going to come out of the power supply into this block. Click that in there, and the 0 volts from the power supply will come into this block. We then have a timer relay, because when the passive infrared activates, it only comes on for a short period of time. Now I need to time how long this actuator takes to extend fully and then retract. So when I've seen how long that takes, if it's 20 seconds, I can then set this timer relay to 20 seconds, 30 seconds. So when the passive infrared detector triggers this will stay on for that period of time, be it 20 seconds, 30 seconds. That will then power the actuator to extend, and after it's got to the end, maybe a few seconds, this timer relay will deactivate, causing the actuator to retract, and so it'll open and then close the coffin lid. So we have a little relay module here, and the relay module for the Lightorama input to basically inhibit the prop when it's not running. And these are going to be mounted on a post separately, so as the passive infrared is near to the pathway, and the coffin will be set back a little bit. So there'll be a cable running from this unit to this box, which will be inside the coffin, and that will contain the book regulator. This lamp, now this runs at 5 volts, so that's why we've got the book regulator to drop down the 12 volt supply down to 5 volts to run this. Now if this doesn't give out enough light, I'll probably put a second one of these at the other end of the coffin. It's just to give it a bit of mood lighting. So we have a IP rated connector, which is a 3-pin, and this will bring the 12 volts and 0 volts to the actuator, and that will reverse for the direction. We're then going to run a couple of diodes from there, along with a 12 volt feed down the third wire to power the book regulator. And obviously, because the other line switches, the polarity switches, the 2 diodes will give us the return path for the 0 volts to whichever line is 0 at the time. So hoping all that's going to work as I anticipate. Sketched out the diagram for it, but obviously we shall see when it's actually running. So this is all going to be connected up, and this put together, mounted in here. Now the coffin itself is made from chipboard. Now the thing is, this is going to be outside for a couple of nights, so chipboard and outside environment does not work well together. So I've ordered some sealant. It's like a resin that I'm going to coat the entire coffin in to try and seal it from the moisture. It's like a polyurethane, clear polyurethane, which you paint on. So I'm hoping that will give it enough protection for the couple of nights it's out each year. And then inside the coffin I have bought a full-size skeleton, which I'm going to put inside, and probably use a little bit of fishing wire to connect to maybe the hand and the head, so as the coffin lid opens it will sort of make the skeleton lift up a little bit, just for a bit more effect. So hopefully that is going to be a nice new addition to our Halloween show this year. So I will build this up and take a few more videos, time lapses, and hopefully by the end of the video we'll have a working prop. Hello. Well, it's been a little while since I posted a video, so I'm gonna put one together now. This is a new prop that I'm putting together for Halloween. As you can see here, this is the lid of a coffin. I've been looking for one to create a prop for quite a while, but they don't come up very often, and I dropped onto this one. So this is the base coffin. It is an actual unused coffin. So we have the coffin. Obviously it's just lined with the plastic, so it's going to have some work done. Okay, it's been a few weeks since I did the video on the plans for my Halloween creation. In that time I've built the control box, which we can see here, and I've got to move my attention now onto the coffin part of the Halloween display. That'll be in a separate video. So we have the control box, and sitting on the top is a PIR, passive infrared receiver, and the idea is this will be placed in the yard, and when the Halloween lights are running this will be activated, and any trick-or-treaters that come up the driveway will walk past this, and the PIR will detect them and start the sequence of the coffin lid opening and the skeleton sitting up. Once that's opened and the skeleton sat up, it will then reverse, the skeleton will lie back down and the lid will close. And when the lights aren't running, this box will be inhibited, so it's not going all the time. So we have the control box. Let's open it up and have a look inside. Okay, so on the end of the unit we have a data in and data out. This is this will plug into the Pixie, one of the Pixie controllers, and one of those channels is how I'm doing the inhibit circuit. But I've put a Pixie out tail, so the rest of the 169 channels can then be tagged onto the end if I expand the display in that area. We've got a mains in, which comes in on a blue socket, which I have blue sockets on my main controller, all IP rated. And then we have an output which goes to a multi-connector, and the multi-connector goes to the control box that's inside the coffin. So in the unit itself, oh yes, we have on the end, if I tilt this up we can see, there we go, we also have an LED here which is to show me that the 12 volt power supply is operational, and we also have an override button here which is a momentary switch. So the idea of that is, if I need to get into the coffin at any time, whether it's inhibited or not, if I press this override, the coffin will open if this is powered up. So in here we have a 3 amp MCB, which then powers this 12 volt 5 amp power supply. And let's turn this around so we can get a better look. Then we've got some connections here. We've got an earth rail, we've got a plus 12 volts, we've got a 0 volts, we have a 12 volt which is from the Pixie line, and a data in, data out. So the data in comes in and onto this rail, and then data out back on that rail. Here we have a timer relay, and here we have the inhibit relay. So basically when the PIR triggers and it's not inhibited, it will trigger the timer relay. The timer relay then activates for a set amount of time, and I've measured this so as it gives the actuator time to fully extend, wait a few seconds, and then it switches off. When it switches off, the actuator retracts fully. Now the inhibit, on my display I have 12 volt Pixies, I have 12 volt and 5 volt RGB, so I thought I'll use one of the Pixie channels, because each port on my Pixie controllers will run 170 separate Pixie lights. So I've taken one of those and basically brought the signal in, and then I've stuck a piece of pixel strip. So this pixel strip has a WS2811 IC and 3 LEDs, and I bring the data in to the chip and then out the other side and back out to carry on. And with this inhibit relay, it's set to operate on the negative side, because with LEDs they have a common 12 volts, and it's the 0 side that gets switched to make them illuminate. So I needed a relay that was triggered on the negative side. Now this board, these are readily available on Amazon, eBay. You can select with this jumper high or low, so it's set to low, and I've soldered on a little jumper lead here onto pin 1 of the WS2811, and that comes up here and triggers the relay. That's basically the control box there, and if I close that up, and if I get the other part of the controller, which is just to the side here, let's bring this in. There's a lot of wires. Okay, let's bring this in. let's move that box out of the way and bring this one in. So this control box is going to be inside the coffin. We have the signal, this is the data and power coming in, which comes in here, and then we've got 3 cables here. So we have a cable out to the actuator, and the good thing with these actuators is that they have limit switches built into them as standard. So you basically have 2 cables here, and when you apply the power onto it, the motor runs and it extends the actuator out until it gets to the limit switch and then switches off. You then reverse the polarity and the actuator comes back in until it gets to the bottom and then shuts off. So we've got a signal coming to this. We also have a little switch here which is going to go on the side of the coffin, so as when the lid lifts it releases this, and this is to turn on the illumination inside the coffin. So what I wanted was a type of a flickery effect, so what I've done is bought one of these. Now this is actually a TV simulator, and you point this at your window, and it's got rows and rows of LEDs, different colours, and it switches them on and off different times. So the projection from it, the colours slightly change, and it looks like there's a TV on. And obviously this takes hardly anything to run, but it looks like the property's occupied. So I got one of these, and we've got another output from the control box which comes in on this, and this will sit, and this will be screwed into the end of the coffin, tucked down out the way, but it will then illuminate the coffin in different colours, different brightnesses, flickering. So that should be quite a nice effect. And then all this has got to be fitted in the coffin. Now I showed you the coffin previously, so that'll be the next process, and I'll put a bit of video together when that's done. Thanks for watching.